All right, welcome. Thank you everybody for joining. My name is Yufeng, and welcome to these adventures where we explore new and interesting concepts, tools, and ideas, usually live. My name is Yufeng, and I'm excited. Today we're going to be looking at object detection in TensorFlow. So this is something that I've kind of explored on and off a bit in the past, and what I wanted to do today was look at how we can use object detection and wrap it up in a slightly better environment than what I was doing before. So in the past, I was following the TensorFlow team's best practices around creating a VM environment, basically setting up my virtual environment to have the right libraries installed and figure out how to deploy these things. And along the way, I've run into various difficulties in doing this. And one of the things that I want to be able to do is share these environments with other people. And so in order to do that, I need a reasonably easy, reasonably straightforward way of sharing these installed environments for consistency. Let's say I'm trying to communicate to a group of 50 people. They all have their machines, and it's like one person's on Python 3.6, one person's on Python 3.8, somebody's on a Mac, somebody's on a Linux, somebody has an older version of a thing, and somebody's got 5 partitions on their hard drive, and it just can lead to, let's just say not as fun times as I would like to have. And so the idea that struck me was, wait, isn't that what containers are all about? Can we package up all of these dependencies into a container purpose-built for object detection, and specifically that not only allows us to do training, but also exploration, and as well as allowing us to deploy these. Because here's the thing, right? We saw on a previous episode of Adventures with Yufeng that you can point AI platform training at custom containers. So how great would it be to have a base container that you can then configure a few arguments and point it at your data set and be able to train those models straight from this kind of base container once you have your data set up. So let's switch over to the code. And what we'll do here is I got a notepad set up so I can take notes. And this time, unlike last time, I remembered to turn on my VM, so that'll save us, 30 seconds. And we'll pop open Jupyter Lab here. And what I've also done is I've collected a few resources that hopefully will help us get started. What I've noticed is that the current kind of state of things online is that there are a few resources dedicated to containerizing object detection specifically. But a lot of them are either relatively old, a few years old, or only do a subset of what I want to do. So let's list out our requirements here. So let's call this object detection containerizing. Containerization, short. My fingers type other things than what I say. That happens. And what we need, of course, we need to install TensorFlow. We need perhaps, let's also say we want GPUs, right? It's object detection, they're pictures, GPUs, they're gonna be a huge help here. So we gotta have GPUs and associated drivers. So we gotta figure out how to get those squared away in our containerized environment. What else do we need? We want to specify that we want, let's say Python 3.7, let's just say something recent, something stable. And I'll say TensorFlow, I'm going to hold off on specifying which version of TensorFlow, and we'll see shortly why. And a lot of it has to do with what is really available, what is supported with the TensorFlow Object Detection API. So if I paste this in here, you'll see what I mean. We go into the library, TensorFlow official repo here, and we go into research, we go down, we find models, and we got to go to object detection. Here we are, object detection. So you can follow along the URL here. We're at research/object detection in the models repo of the TensorFlow organization. So if you go to the TensorFlow GitHub, that's not what you're looking for. You got to go up a level, right? Because this is the TensorFlow organization. This isn't the TensorFlow library. This is the models GitHub repo. And so here we are in object detection, and this is kind of going to be our home directory that we're going to work off of. And if you're joining us, I want to also point out that this is a live stream, so you can catch the chat, either the live chat over here or down below. Be sure to say hello, and if you have any questions, throw them there. Also, if you have any thoughts on particular data sets, preferably open data sets, that you would like to try this on, post those there, post a link, we can explore that. So TensorFlow, we need to have, what else do we need to have? Various associated libraries. We'll keep adding to this list as we go. So I mentioned earlier that the existing kind of prior art, if you will, sometimes falls a little bit short, right? So here's one example, building object detection with Docker. Like, that seems like exactly what we want. Why are we making this video? I can just read this tutorial and be done with it. One is that it was written in December 2017, so we should expect some things to be out of date, but that doesn't mean that it's not valuable. So let's take a look at what it has us do, right? This is running off of Ubuntu Bionic, and it installs more or less the relevant libraries. It acknowledges that Object Detection API requires a bunch of dependencies that are perhaps not commonly used, everything from protobuf to tfslim, which is kind of a old days wrapper library built around TensorFlow 1. And this is kind of my point about TensorFlow there, kind of needing potentially 1.15 rather than TensorFlow 2.x, unfortunately. And so, at that time, TensorFlow 2 wasn't a thing, so it wasn't like controversial at all to install an older version of TensorFlow to get what you wanted. You have to compile your own protobufs. You'll need to export some particular paths, in particular appending the Slim library. So we're actually appending the source library. And then what they do is they open it up for a Jupyter notebook to be accessed. So this Docker file is designed for experimentation. It's very much, you can see down here, designed for creating a container that you can then connect into, and you can see when they run the image, once it finishes building and all the errors are passed, you run the Docker container, and then you open up localhost, type in your password, which we set in that Docker file, I want to say, with root, allow root, and if I go back down, yeah, our password is just root, and then you can open up the source code as needed and play around with it. This is very suitable for our experimentation needs. And you'll also see, if you look on this image, it's actually running Python 2. I hope we're not stuck with Python 2 for this. That would be unfortunate, especially since newer versions of TensorFlow don't even support Python 2 anymore. So we'll see what happens when we try to do that. But it's really just for experimentation, not so well suited for running training jobs, right? So let's now turn, well, there's still valuable stuff here. So I'm going to leave this open. Let's go on now over to the next tab. Here I've got another guide open. This is now getting a little more recent. We're April 2018 now. This one's all about putting together a container to process videos frame by frame. And so if we just cheat ahead here and get to the end, you'll see what they're using. Where is it? Maybe I'm misremembering which exact thing this one is using. I'm thinking of different guide perhaps. Oh no, I'm thinking of the right one. So they're running the Docker container directly with a number of different environment variables that point to the video files where they want it to be pushed out of, these xauth and xsock environment variables, and doing a number of kind of manipulations of the file. But this gives us a interesting look into using a container as kind of a job runner, right? So this is the Docker file they're using. We can see they install TensorFlow. Notably in both of these, they're not installing TensorFlow-GPU. And remember, that was one of our requirements. We wanted a GPU-enabled image, so we'll have to do some work to hunt that down. And so now let's turn to continuing onwards. Right? This is kind of standard. We'll see a lot of similarities here. We install the relevant libraries. We compile a bunch of protocol buffers, and they also will install OpenCV accordingly. And so this one also points now, I haven't looked at this before, the work here described in a different article. So I'd like to dig into the articles a little bit just to make sure we didn't miss any particular pieces. So this is just all about Object Detection API as itself without the containerization part. It's a relatively short article, a lot of conceptual kind of talk. So I'm going to close this for now, and if we need it, we can always open it again. This one is particularly interesting because we can see here GPU Docker featured, and that's quite useful. Oh, we have a question from Kumar, and he asks, is there any reason why I can't find Yolo under the models? That's a good question, Kumar. Let's take a brief side tour here on the Yolo model. So Yolo is going to have lots of funny autocompletes, but Yolo, you only look once. It's a machine learning model, and the short answer is that this model was not, it didn't come from Google, right? So this is it didn't come from TensorFlow specifically. So this is the TensorFlow models repo. I suppose they should or maybe could implement it in TensorFlow. So this is the original paper back in 15, but revised in 2016. We're at version 5 of this paper now. And we can see that the original site from PJ Reddy is here. It's a very kind of old school Web 1.0 vibe, but it's very effective. And this is kind of their site, and it works. It's a quick model, if I remember correctly, that runs especially well on kind of limited capacity devices. And so it uses Pascal VOC as the data format, and we can talk more about Pascal versus Cocoa versus other data formats. They're just ways to describe these bounding boxes on the source images. So if people want to hear more about Pascal versus other image formats, we can talk. Let me know in the comments, and we can dive into that more. And let's see. So yeah, this is the basic reason why Yolo isn't there. It's kind of its own thing. It's a little custom model, basically, for lack of a better term. Okay, so going back to the Docker image and GPUs, this one gives us some insight into how we might set up a Docker container to allow it to install the relevant GPU related things. So we can see here, this is pulling the TensorFlow GPU version. It's doing 1.5. Don't mistake this for 1.15, right? 1.15, which is the most recent and final TensorFlow 1 release, at least as far as I know. It doesn't have the NVIDIA drivers being installed here. So this is worth keeping in mind, that we still haven't quite solved that problem, though you see it does take care of listing out all these other libraries, codecs and things to be installed within Linux, which is good to see and keep in mind. Let's move on over to my final, this is the Docker file itself, right? So this is the 3 things. You'll see that it also uses Python 2.7 here, for better or worse. So we got a little bit of work ahead of us. A lot of the features that we're looking for, GPU, most recent version of Python, and most recent version of TensorFlow 1, that intersection of these 3 factors isn't really satisfied. So where does that leave us? I've spun up the notebook that we've been working out of, and this will give us kind of a machine to kind of do our terminal work and create Docker files and the like. Now, the first thing I want to do is pull down the TensorFlow models repo. So I'm going to click that in a new tab. I'm going to click this, copy that out, and you can see this reflected in the installation and kind of quick starts. But let that get started. And what we'll do, let's see, we don't need that. We don't need that. All right, so what we'll do is take a look at some of these installation instructions, right? There's installation of the library, and this is what we'll want to mimic in our Docker file. So for instance, we want to make sure we install this. So I'm going to take some notes here down below. And that command I just ran to clone that repo, we're probably going to need this source code, the toolkits installed in that source code, so we'll include that. And we'll see how close I can get to some of the examples that we saw before. And we see that they go ahead and ask us to install all of these dependencies, which in some cases are also available via pip. So I'm just going to do the pip version for now. We'll see if that comes back to bite me later. Let me make this file sized correctly for our windows. Great. All right. So then we have, you can, okay, so it makes a note that for protobuf 3 plus versions, we might have to use sudo apt-get install instead of other methods. You'll also notice that the pip install of some of these, right? LXML is in pip install. Here it's up here. But not all of them are really covered here. Protobuf compiler, pill, things like that still need this line. So I'm gonna take back what I said earlier and change this and put this here instead. Great. And we'll see how that goes. This uses the Cocoa API, so if you wanted to pull out your data sets through that, you'd want to do something like this. For our cases, we should go ahead and do that. And we should make a note that we do need to adjust these shortly because you'll notice that this says path to TensorFlow, not anything more meaningful than that. So we'll keep that up to date as we go along. We need to run this protobuf compilation line. You'll see that this is the same line that we saw featured, let's say, in this Docker file. I expect it to be somewhere in here. Here it is, proto C, and then it does this proto Python out. You'll see it in these as well, I suspect, somewhere. Here it is, and proto C, and then in the this article, again, we see that same command. So we really got to make sure we don't forget to run this command. So I'll drop that in there. And what else do we have? We have manual protobuf installer. So what's interesting here is that I'm on Mac, but the machines that we're running on are Linux machines. So we'll need to take the Linux instructions from here and run this, and we'll use the downloaded version. Interesting. Is this? Okay, so this, I was going to say, I don't remember running all of these commands. This is for if this line doesn't work, right? If you get errors, use the following manual installation. So hopefully, fingers crossed, we're okay. We don't need to worry about that piece. And we'll go on. We want to add some libraries to path so that tf-slim can be found. For better or worse, TensorFlow Object Detection API uses tf-slim, and then there's a tester. So what we'll do is we'll run through these instructions locally so that we can see that they work. So we're going to run it in this kind of notebook image, and you'll notice that earlier in the week, the other day, we tried this ResNet thing, right? So it pulled this was from, what is today's Wednesday? From Monday, we did a little hyperparameter tuning episode and used the hypertune libraries, right? So this ran through this sample set. And if you missed that, you can catch that. It's on this channel. This will all go in the same playlist as well. And you'll see that it's pulling the file from the Docker file -GPU. So it's grabbing a GPU-enabled deep learning platform release image. As it happens, this image is the very same as the one that we are using right now. How do I know this? Well, when we created this image, I'll show you here. If we make a new instance, I'll ignore all this stuff, ASDF, and you can see here when we choose the environment, right? This is where it's all defined in combination with all the other kind of machine types and whether there's a GPU and things like that. So I'm going to click on some of these learn mores. If it's not here, it's in the deep learning container instances. So I'm going to open that just in case as a backup. So this is talking about the TensorFlow versioning. Okay, so that's not quite the link we're looking for. This is the container image, which was said, look at, and this is just for GPUs in general, making sure you have the right region. If you want a V100, you want one GPU, you have to pick one of these regions. And as we found out on Monday, one of the regions that notably is missing is US East. Right? Where is US East? Also Europe East. Only Europe West is featured. And so if you're on the West Coast, or if you are happy to connect to US Central 1, then you're good to go. But for those of us on the East Coast, we'll have to choose from this list and not have access to V100s on US East. Interestingly enough, are any GPUs available in US East? Okay, there are some. So what is this one? The T4, that's a relatively recent one. We got the P4, also a fairly powerful machine. And we have P100s as well, also available on East. So it seems like it's primarily, and of course K80s, so it's primarily the V100. So lucky me for picking the one GPU type that I couldn't get on the East Coast. That's pretty funny. All right, so in terms of choosing the container image, I'm trying to find the list of these kinds of GCR.O deep learning platform release. I bet what I could do is I could go to the container registry itself. If I go to here, rerun that page, and because these should be publicly visible, images. Okay, found my images. Can it find other images? Maybe. Let's try something like this. No? What about if I copy this? Because that's like kind of the username, and this is, could that be the project name? Ooh, look at that. All right, I gotta get this link. Very, very handy. Keeping that for later. So we see these are all of the images that are available. And so this is way more verifiable, essentially, than if you were to look at the documentation and say, oh, the docs say this image is what, or that image is such. Here we can directly see what is actually loaded into the Google Container Repository. And you can see there's TF versions, CPU and GPU. Let me crank up the size here for a moment. And we can see that there's also TF2 CPU. I don't know what CPU.2.0 is. Those are good questions, I suppose. And then there's TF2 GPU. Oh, I see. It's TensorFlow 2.0 and 2.1 would be my guess, as well as the GPU corresponding values. I'm not sure why there's one without anything after it. I wonder what that one might be. But what we care about is we want GPU 1.15, so that would be this one. So we can click copy, and that copies this whole repository name, not only the this short name by itself. And so we can put that kind of at the top of our thing. And so one of the terms in Docker, one of the keywords is from, and you can see that reflected in whichever file we're looking at here, right? It's from this path, and you can see it's the same as the one that we found. So that's reassuring. So that's the same image as what we're working with here. And so everything we do should work the same, exactly the same. So everything we do, we want to keep track of and kind of have that reflected in our Docker file. In fact, why don't I do that? Why don't I go ahead and say I want a new text file. I'll rename it later. Call it a text file for now, but we'll do a little switcheroo on it at the end with a extension renaming. So let me paste what we've got so far. It's a working file, and let's see. We can just not Control Tab. Let's save that, and then this should show up. Untitled.txt. We'll move untitled to Docker file. Great. And what we want is, so everything was under models, right? Because we cloned models.git. And I'm going to take a peek at one of the other Docker files that we saw earlier just to make sure we're on the right track here. So we're going to start from something. Perhaps we should run apt-get update, though we don't necessarily have to. These are like stable images that are already set up. I'm almost nervous too, because you might end up in a bit of trouble. Here what they're doing is they're going to run makedir and create TensorFlow/models and install that there, and then clone it into TensorFlow/models manually. Very interesting move there to have it set up that way. I'm curious how the other ones are doing it. So this Docker file is happy to just get cloned directly into the actual TensorFlow installation folders directly. Interesting as well. So it's installing TensorFlow. It knows where it's going to be, so it can kind of pre-find it. I suppose that would work. If we have any Python packaging experts in terms of best practices there. That would be interesting. And then it sets the working directory once it's done downloading everything. So let's at the very least have this, keep doing that. We should close this, open Docker file. It'll be the same thing. Hey, it does the formatting. Appreciate that. So we should run pip install TensorFlow-GPU. Because we're starting from a base image that has the GPU tag on it, we know that I hope it's implying that all of the drivers are already installed for us. So assuming that that is correct, we can go ahead and look at what else we wanted here. In terms of the instructions in the quick start, we pretty much copied that over. I want to compare to see if there's anything I might have missed, right? The instruction set to install TensorFlow, git clone this line, which we'll go ahead and do. So we have to make sure we hit run and anything. It's not a bash script, so it won't just run it directly. It's gonna get, it needs to install Python. It doesn't need to install Python. So because we're starting with not Ubuntu, we're starting with something that has a lot of pieces installed already, we will be all set. In particular, it's occurring to me that I don't even need to run that line, right? Because that is coming from our base image. TensorFlow GPU is installed, and in fact, we can prove that to ourselves by running pip freeze and grepping for TensorFlow. And so we can see that TensorFlow GPU 1.15.2 in this case is installed. And so we don't need to worry about it. So, but we do need to get the models repo, and I think it'll be okay for us to clone it not into the TensorFlow kind of folder in terms of like where pip is keeping it all. And then we're gonna install all this stuff, and I think we are gonna have to run it with sudo. I don't think we can get away with not doing that. So I'm gonna do that. Press enter, and the usual lecture from the system administrator. But what would be the password for Jupyter? I'm going to control C out of this and try running this without sudo. See if I can get away with that. All right, I cannot. Let's say the password is nothing. Is the password nothing? Ooh, this is a bit awkward. What would the password be to... Can I even run like apt-get update? Like, no. And if I run sudo apt-get update, if anybody has any thoughts on that, that would be useful. In the meantime, we will turn to some help on the internets. Let's try searching for deep learning VM sudo. Unable to do sudo. Good old Stack Overflow. It is never enter deployment name will be the root of your... I was hoping maybe the official docs would say something, but it doesn't appear like... Let's see, we should have a strong answer on this. Fix has been renewal. Wow, this is actually quite elaborate. So if I go over here, this is the public issue tracker. Delete. I must be using it the wrong way. Maybe that's a strange way of looking at it, but I feel like add a SSH key, log in with another SSH client. Because part of it is the fact that I am kind of going in through my, it's the exact same thing. That's great. I'm going in through this link, right? I'm clicking open Jupyter Lab right here, and so that pops this open, and my user, who am I, is Jupyter. It's not my username that I'm using to log in. I'm using a service account basically, and so what would the password then be for this service account? Let's take a look at any other. Okay, there's some suggestions on how we can get the root passwords. According to, you can use, all you have to do is install. Let's see, getting the root password, slightly different. The VM in the cloud don't come up with a root password set up by default, so you'll need to first change the password. But it's not a blank password, there's just no password. But there's no way it's gonna let me run this without having sudo, right? Let's see. Yeah, that'd be crazy. Any thoughts here? You can do it through the SSH. It works when you SSH through Compute Engine console. Yeah, that's true. The sudo will just work if I'm doing the reverse proxy from a local host. It's a shame, but it looks like that might be the best way to get around this particular issue. All right. I mean, I've certainly encountered worse. Let's just say there are worse ways to go. And we only need the sudo for a few things. So let me go over to find the docs that I'm looking for here. Ooh, how will I find this? It's a test of how well I know the documentation. So let's see, if we go from the top level and we go to guides and resources and maybe here. And okay, let's just use search. Oh, it's probably under products. That's what I get for. No, I did hit products, didn't I? But I somehow ended up on resources. Okay, here we are. Deep learning containers, deep learning VM images. Because I know in the docs there's a little snippet of code for properly doing that reverse proxy. It's like -L 8080:80, something like that. So connecting to Jupyter Lab. Yes, this is what I'm looking for. And I have to do it from my local command line, unfortunately. So let's see, we'll get our project ID, which in this case happens to be called Cloud ML Demo. And our zone is based on where that VM is. Where is that VM? I don't remember where I put it. US East 1C. US East 1-C. Yep. And then our instance name was TF-1-15-GPU. And the rest will stay the same. So I'm going to run this command in my local terminal, and that'll allow me to run localhost 8080 and connect it to this machine. All right, we need quotes probably because I put a bunch of dashes in. Oh, it's because I put a $sign in. Left the $sign behind. All right, with any luck, it won't reject me or do something horrible. That's been known to happen too. Oh, I suppose I could have just clicked SSH. Yeah. If you click on this, it'll take you to Compute Engine. And then I can just click SSH, as we saw in that first episode. I can just click this SSH button. So if there's something weird going on with networking, I'm just going to click SSH. And I'm working on the terminal anyway. Like I don't need the Jupyter piece to begin with. So I'll quit out of that, and I'll just SSH. And because what we actually wanted to do, we've been so distracted, I apologize, is simply, I don't even remember, what was the command we were trying to do? We're trying to install all these libraries. Yes. So this will work now that I have permission. Interesting. So it asks this question. So how can we, I believe there's a -- yes. Okay, so we want to add that to our controls so that we don't need to acknowledge a yes. Where did it go? This. Brilliant. So that all sort of went through. There's some complaining there, but that's unavoidable complaints from the computer. And next we have some pip installs to do. I want to see if pip3 is if it exists or not. Okay, pip3 exists and pip also exists. Are they the same? Which pip? Which pip3? Okay, but it is in Anaconda. Interesting. All right, to be safe, let's just do pip3 because yeah, they added Anaconda support now. So maybe we can test it, right? We can install like some trivial library and see if it's there. But a lot of libraries already are installed. So if I run pip3, install the Cython thing is the most interesting thing to me. So what's interesting here is Cython is already in this. So I'm going to scroll up and show you this. Luckily, because we're working from this deep learning container, we see that Cython is already installed and it's in Python 3.7 site packages. Context lib2 is there. Of course, Jupyter is there. We knew that. And finally, matplotlib. If we want to output any plots, that is also already installed. And it's also in Python 3.7. So let's keep it that way and make sure we have that Python pip3 line in front of the install commands. Oh, I'm editing the wrong file. What we want is to be here. This will now be replaced by that. We've added the -- yes, and we've added a 3 after the pips. Next, we want to install the Cocoa API. I believe in this setup, we don't care to change the directories just yet, but we do need to run slightly different commands. So you see here, you can run things like makedir, but if you want to change the directory, we don't run cd. You just say workdir to change that, right? So we're going to change our working directory to this folder and then git clone it. Of course, we haven't made that directory yet, so we might need to run a makedir. I'm surprised it doesn't talk about that in this. Let's do, where is it? Did I scroll past it? Okay, so did we not run the git clone? Or did I put it in the wrong order? That would be embarrassing. Git clone, then we cd, then we make, then we copy. Yeah, I put it in the wrong order. How did that happen, I wonder? All right, let's run this. And we're going to run all those other commands too. So we should be able to type run. Gotta love that alt typing. And then we got workdir and we run make. Run make. And then we want to run cp. We're in this directory. Then we need to go to this path. So where did we install models.git? That is a good question. And now I see why they've set these directories so explicitly. Every time there's a git clone being run, they make sure that it says specifically what folder to put it in and that they made this folder beforehand. So let's go ahead and do that. I don't see any particular harm in including that. It's an interesting way of doing it. And they run it, and then when they git clone into that folder. Seems fine. So we just have to remember TensorFlow /models is a thing. And we have this git clone. So what folder are we in at this point when we do that though? We make this model, we get the installation. We just run pip blindly here. And then make folder, we copy the thing, we set this. Where is the installation of the PyCocoa tools? They skipped it. Huh. Suppose it might not have been relevant at the time or for their use case, but that's interesting, certainly. And they want to end up eventually copying it you can see here, into models/research, which in our case will be TensorFlow/models/research. And so in a way, it doesn't really matter where this ends up being made. But we do need to set our working directory to be this after all that's said and done. And then we copy it, we run this, because we're now in this, we're already here, we're in object detection, right? So it's /research/object detection. And so we know this to be correct because we were in our folder here. We're in our root folder, which apparently is empty now. Because I'm no longer in the Jupyter folder. So let's try it from root, right? Let's follow these instructions. We say we want to do it for real, so let's do it for real. And we can't put it in root because in the container it's not root. So this is one of the tricky things, right? About working with not quite the same environment as your container will be. You don't have the same permissions. And so if we just put it in here, we just have to like kind of pretend, we fudge it a little bit. And it's going to download to that virtual machine again, but in a different folder, different home directory. These are still going to be installed because that's at the top level, I want to say. It should still go. I mean, these were already installed, so we don't have to worry about that. I would argue almost removing it if you had strong kind of compute constraints and time constraints. But let's git clone this. And so we have models, and what we're going to do is we're going to git clone this side by side with models. So now we have models and Cocoa API. And so now we can cd into this and then run make. And once that's built, we're going to copy it back out. But what we're going to copy is not exactly to there because that's not exactly where it is, right? It's actually in home/models. Like so. Hopefully I did that right. And then we want to cd back to model/research, which in the container version is root TensorFlow/models.research. And so that now we're in this home directory. And now we can run this command. And it's one of those things that just like runs and you're like, did anything happen? It just went so fast. So it is an awkward thing. We got to export these command line variables, these what we call it, environment variables, and we've got. Let's check our steps here. We did our protobuf compilation, and just for our own sanity checking, what we want to do finally is run this model builder test, and it's going to test our installation by loading up TensorFlow and loading up the TensorFlow Object Detection API and seeing if it all works. So it says here, if you see a dependency listed, it can potentially be an issue. So let me move this fully into view properly. Apologies. I'm going to run that again since it kind of did some funny line wrapping there. But the crux of it is it looks like it's okay. I know this says it's skipped. I honestly don't know why. And yeah, that's the extent of it. It always seems to be skipped when I've run it, and it hasn't really come up as an issue. But all things considered, the steps seem to work, and what you'd want to do next in this Docker file, right, is to pull in any relevant code for your situation, your source code. And we saw examples of that, for instance, here. Once it finishes, it sets the working directory that they want to really be working in, copies in any training code, model code, and then selects an entry point to run in terms of like, what is the code you actually want to run? And you'll notice that you can put these pound signs in front of the folder names. So we'll be sure to do that here because we're not really quite ready for doing these steps. So I don't want to forget them. So copy the trainer code somehow. Don't forget. Okay, so in the guide that we were kind of working off of, the original one is it uses the pet dataset that comes from the kind of what's called the Oxford 3T pets dataset. And there's various breeds of cats and dogs in it. And what it'll do is, in the end, it tries to fine-tune an object detection model on these kind of on the base data, and it uses a kind of faster RNN ResNet 101 model, which we don't have time today to kind of go over. That might be an interesting thing. Oh, question here: do I need Cocoa API even if I'm doing my own tensor records? So this is an interesting question, right? We saw that perhaps we don't need this Cocoa API based on what some of the other kind of Docker files we're calling for. What I thought was interesting though is that it makes this Cocoa API and copies it into this position, model/research. So let's take a look at that, right? We see that it copies PyCocoa tools. So what is PyCocoa tools? It's listed here. It's a folder, so we can cd into PyCocoa tools, and let's see what it looks like. And so it's a number of Python scripts and C code as well, and a shared object file that got built by Make. And it says here that we can copy this into this if you're interested in using Cocoa evaluation metrics. So it's an if. If you're interested in using Cocoa evaluation metrics, then you don't need these, or then you do need these. Otherwise, what you'll be left using is the default metrics, which are based on those in the Pascal VOC evaluation. And so if you want to take advantage of these Cocoa evaluation metrics, you want to add this line, metric set Cocoa detection metrics, to the eval config message in your config file. So when you use this API, there's a config file that you fill out, and you can select what metric set you want. And so this is kind of giving us clarity on how to access the Cocoa evaluation metrics as opposed to Pascal evaluation metrics. To use the Cocoa instance segmentation metrics, then there's this for image segmentation similarly. So I suppose we went through all that trouble potentially for nothing if you're not interested in Cocoa. And more specifically, I think the reason why they've included it here is I think this data set for this getting started at least does use Cocoa style data. And you can see here it makes sure that you have all these things set up before it submits a training job. So this is similar to kind of submitting a custom container, but instead of containerizing it, it is submitting a tarball with your source code and just your source code. So it's a little messier. Using a custom container can often be a little bit cleaner, and you kind of know what you're shooting off more clearly. What I'd also now like to do, let's see, with the time that we have left, I want to at least show you something. So here's this Jupyter notebook claims to have off-the-shelf inference. So this is the object detection / object detection library. Did we ever clone this thing into here? Yeah, we did. So this is models. Here, I'll navigate in the folders. Models, research, object detection. So it does pull down a lot of extra stuff. Like this is now our working directory and what we should be working off of, and like all of these folders, including things like the dataset tools, are really, really handy. So then here's the object tutorial notebook, right? So if we wanted to, we could run this top to bottom, which I don't see why not. Let's try run selected cell and below. Just let it rip, right, while we talk through it. So it's going to install, for some reason, TensorFlow 2. So that's funny. This is one of the things that I've kind of struggled with working on this, is that the instructions say to install 1.15, but then when it comes time to do installations, it will kind of do some funny stuff in terms of doing predictions. When it wants to do out-of-the-box predictions, it'll often use Python 2 instead of Python 1. So you can see this is the big output from installing TensorFlow 2, and it has some compatibility complaints that I'm gonna temporarily ignore and cross my fingers that it works okay. And here, this is the pip version of installing PyCocoa tools. It which we hadn't done yet. We do some working directory manipulations. It runs the protobuf compilation, which happens in a snap, and then we go and install the local kind of library requirements in model/research. And finally, we are ready to run some code. It grabs the model from, you'll see here, it creates this little function for grabbing models, taking in a model name, and it grabs it from, like there's lots of different models for object detection. So you can see here that there's mappings from their paths to their labels, which is a way of describing kind of when it predicts a number, we know what actual text label it corresponds to. And this is the model that we're going to choose to use, and this is where we're going to have a failure. Let's see what we got. Load, required, missing, tags, and export dir. Whew. I do not know if we're going to be able to save ourselves from this. I suspect this is a side effect of using, yeah, it's a v1, v2 problem. This function is only available through the v1 compat library as tfcompat.loader.load or saved model.load. It looks like this one wants to be the saved model.load. So a lot of times when you run into these compat issues, you can see here, oh, I can't point at the screen, tf.savedmodel.load, that's where the error was. And the compatibility library is compat.v1. So if you imagine inserting right here, compat.v1, it would read tf.compat.v1.savedmodel.load. And that's exactly what we have here, tf.compat.v1.savedmodel.load. So let's go ahead and fix that by changing this line here. Right, we want to use that call instead of what's provided. Specifically, we want to insert this into here and add a dot. So we don't need this anymore. And we're going to rerun this cell. Everything else should be okay. I'm running it out of order technically a little bit. All right, next we have load, still missing these arguments. So even though we're using the v1 compat, it still does not like it. I really wish that we had perhaps tried the other one. Maybe it really wanted the other one. So I'm going to do this again just to trigger that error one more time and see if it will. Ooh, it won't give it to us. It won't give us that error again, which is unfortunate. Does anyone remember what the error used to say? Got to rewind the live stream. And let's see. Let's search for this. Tags. Save model.load. This is tf2. Tag export dir. Okay, so it looks like I can potentially just say export directory directly. Required tags. This is a set of string tags to identify. Ooh. I'm surprised that this. So this used to work. This is the classic. It worked on my machine kind of situation, right? It worked only a few weeks or months ago. An export directory. So I hope we're not up a creek here. Why can we not get away with a default value? Load, load, load. Now, to be fair, this question was asked 17 years ago, 2 years ago, so it could be rough. It was this one, save model.loader.load. But even that, it requires an export directory. Is that? It could be blank. So model directory. It built up that model directory from earlier. And if we just say no tags, and then we say, let's just say this, the export directory can just be local. You know, it's fine. We'll do compat.v1. We'll save that off, run this, and still no dice. Save model does not exist. Well, yes, of course. That you're supposed to grab it online. That was the whole point. What was the first argument then? Perhaps I misunderstood. Oh, the session. I'm supposed to pass in the session that it wants to use. Ooh, that's going to be ugly. I don't know that I have a session handy created. That doesn't happen until later, I want to say. I wonder what would happen if we tried running this in Colab, or did I just find broken documentation? That would be unfortunate. I think a lot of this has to do with kind of the run. Oh, okay. A lot of it has to do with the versioning, TensorFlow versioning troubles, as well as kind of when this was last updated potentially. These APIs have been changed a lot. What is the recommended fix? So this is T1. So we tried this. No, we didn't try this. We tried the other one. There will be a new function for importing saved models in TensorFlow 2.0. If only this document would tell us what that function might be. Wouldn't that be a treat? I also wonder if this would work if I hadn't installed TensorFlow 2.0 as such. And if I didn't, let me see what it shows up here. Pip breeze grep TensorFlow. What version does it think is available to me right now? It still says, it still sees TensorFlow GPU. That's good, I suppose. Let me go over here and not run this cell, right? And if I don't run this cell, well, and not only not run this cell, let's run that command in the Jupyter Notebook, see what it thinks, what TensorFlow version it thinks is available to it. Well, at any rate, it's gonna need to re-import it regardless, and we'll be able to see it from where it imports TensorFlow down below, right? We say tf.version. Oh, it sees it as 1.15.2. So those compat libraries, it's not going to be able to see that regardless, which explains partly why it's having such a hard time with these compat.1.v1 situations. We tried save model.load. Oh, did we try save model.loader.load? It's like that line from Lord of the Rings, right? Yes, I've had my first breakfast, but what about second breakfast? Yes, and I still have this set up funky. I'm gonna comment this out, and let's see if it'll take that the way it used to be, right? Basically, but with the new, so it still expects these two positional arguments, which is kind of what's been crushing me here. So if I close up this setup thing and see, that's funny, right? It works in Colab, and that has to have something to do with kind of the way that these libraries are being installed. And I'm gonna kind of jump ahead here before we completely run out of time. I want to see what version of TensorFlow this notebook sees, right? So we imported TensorFlow, and here I'm going to add this code right here, and we're going to print off that version. And so it sees that as 2.2.rc2, and so that allows it to perhaps use the latest versions of save model.load. And the fact that we saw version 1 suggests that maybe what I really needed is v2, and that it said, what was it, save model.load. So in v1, in the later stages of v1, it knew about some of the v2 APIs. And save are not created because there are no variables in the graph to restore. Not the worst. So let's see if I can't get this to run on this local environment. So close. All right, so I will keep fiddling on this, but I will cut this for now. Know that object detection does work in here, and we are kind of able to create this Docker file that replicates the instructions. This would allow you to have a consistent environment across machines, across your team. And we have, I missed a few questions from Kumar before he had to go. Do you have any sample code for transfer learning? That's right. So this is kind of the direction that I want to go in here. Is we can make this container and have it set up to execute code for transfer learning, execute code for training from scratch, picking the models, picking the parameters, and so you can just pass in a few arguments and have it invoke it properly. And Kumar says he wants to use the pre-trained ResNet 101 from the zoo, but use my custom data sets and labels. Absolutely. And strip out a few layers, rerun the training. Yeah, totally. And so, yeah, that's definitely what we'll kind of look to figure out for future sessions. And before we jump to that, though, I want to add that this Friday, I'm really excited to have my colleague and dare I say friend, Felipe Hoffa of kind of BigQuery fame, joining me on the live stream. So same time, same place on this channel, and we'll be chatting about BigQuery, of course. What else? And Felipe is a great character. It's going to be a ton of fun. Really looking forward to it. So don't miss out. 3 p.m. Eastern, noon Pacific, this Friday, April 10th. Yep, April 10th. I'll be on the air with Felipe Hoffa for an hour, and we're gonna make some cool stuff. So really looking forward to that. And until then, we'll see you soon.